This video is going to work through the Part B worksheet on natural logs. If you haven't already done this worksheet, which was your homework, can you please try and work through it now? Just pause the video before you get to the answers, which is coming up next. Here are the answers to the Part B workshop. I'm now going to go through and work through each question, and you can just forward the video to any of the areas that you need some support with. For this question, you just really need to know your log laws. Remember that, just to remind you, that this ln is simply a log to the base e, and we write it like this so that we don't confuse log to base 10. So if you see log by itself with no base, you can assume that this is base 10. This is always base e, and remember that e is simply a constant. It's a constant related to exponential growth, and it's equal to approximately 2.7183, etc. It's actually an irrational number, so it continues on. So getting back to this question here, using your log laws, you know that this is the same as 15 times 3, which is equal to the natural log of 45. Now the question doesn't ask you to solve it. That's all the question's asking you to do. If you're going to solve it, you could enter that into your calculator to get an answer. Looking at question number B, the log law associated with this is going to be this, which is the natural log of 5. Question C, this is a similar rule. It's the same as this, which is equal to the natural log of 4. D is going back to the addition and multiplication, so it's the same as the natural log of 4 times 6, which is equal to the natural log of 24. E is also the same rule, so just multiply those together. 5 times 0.2, you can see to the ln of 1. Now you might remember that the ln of 1, that's asking you what integer, what power of e gives you 1, and you know that this has got to be equal to 0, so the answer is 0, because anything to the power of 0 is going to give you 1. So the answer for this one really is 0. For this one, using your log laws, you know that you're going to have to multiply each of these, and that's going to be the log n of 30. G is a little bit different. Here you have 1 plus the natural log of 4. Now what do you remember about 1? You should remember from before that this is just the natural log of e if I'm going to try and express these together. Remember, the natural log of e is just 1, because you know that in order to get e to the power of something to equal e, this has got to be 1. So now we can actually simplify this to the log of 4e, because I'm just going to multiply these together based on the log law that we've been using all along. Similarly with h, if we change these both to a log, we're going to get the same thing as we had before, and we can express that as 1 natural log using the same log laws before that you have minus, and this becomes natural log of 6 over e. This next question combines two log laws, so now we have the natural log of 5 times 8 over 2. We can now simplify that to 5 times 8 is 40 divided by 2, natural log of 20, and that's the answer there. In order to try and express this as 1 log, we need to look carefully at 2. So expressing this as base 2, the base e, what would that have to be? That would need to be e squared to give us 2. So natural log of e squared is 2. That's what it is. So then we're going to change that to natural log of e squared plus natural log of 4. And using our log laws, we can now say that that's 4e squared. I've just multiplied the 2 using my log laws. K is going to use this as well, only we're now going to divide this 20 by e squared, and that's going to be the answer for that one. You need to put a bracket around that. That's how we would do that conventionally. Letter I uses the same rule, but now we've got ln of 12 over the top of 4 times 3, which is equal to log of 1. Now we know that that is going to equal 0 because e to the 0 is what gives us 1. So these are the solutions. Question 2 is asking you to express things in the form of a natural log of 1 rational number. This means rational numbers, and remember that rational numbers are the set of numbers that can be expressed as a fraction as opposed to irrational numbers. So looking at our log laws here, we know that that is actually 3 to the power of 5 plus log of 4. So let's combine those, multiplied by 4. And what does that equal? You can use your calculator if you like, but 3 to the power of 5 is 243 times 4. And that's going to equal natural log of 972. You don't need to figure it out. It's not asking you that. It's asking you to write it in the form of a natural log. So that's the solution there. Again, remember from your log laws that this is the same as 2 cubed, and this one is the same as natural log of 5 squared. So putting those together, we've got the natural log of 2 cubed times 5 squared, which is going to be 8 times 25, which is going to be the same as 4 times 50 or 2 times 100, so that's 200. And there's the answer there. Combining 2 log laws for this one, we've got natural log of 2 cubed over 8. I need to put brackets on that, so that's just 8 over 8, because that's the same as 2 cubed there, which is equal to log of 1. Now what do you know about that? What base e 1, what's that going to be? Do you remember? That's going to be 0, because that's how we get 1 with the base e. Remember, anything to the power of 0 is going to give you 1. Again, letter D, we can combine these into 2 different log laws here. So let's put those together. 4 cubed over 2 squared. That's the same as log of 2 to 6 over 2 squared. Same as, I'll go over here, log of 2 to the 4th, which is equal to natural log of 2 times 2 is 4 times 2 is 8 times 6 is natural log of 16. So that's the answer there. Now remember, I got that because you know that your indice laws, you would subtract these indices. That's exactly how we get back to this type of logarithm rule. Looking at the log laws here, we know that this is the same as log of the cube root of 8. So what is the cube root of 8? That's the same, that's just 2. So let's put that back into here. So it's natural log of 2 plus log of 3, which is just going to be 6. Because we use the rule here, log law here. Letter F, it's 1/3 natural log of 1 on 27. So again, let's look at this is the power of a third, so that's actually the cube root of 1 on 27. So what's the cube root of 1 on 27? That's going to be 1 on 3 times 3 is 9 times 3 is 20. That's just the same as that. Remember that when you're looking at indice laws, so 1 on 27 to the cube, you have to cube both. So it's 1 to the cubed over 27 to the cubed. Now this, to a third, sorry. So this is only going to be 1. So it's 1 over cube root of 27. And that's 3. Remember, 3 times 3 times 3 gives us 27. So the answer, the final answer, is this one. Now this you can just assume, that this is -1. So I hope I'm not going too fast in this. So using the same rules we had before to the -1. Now what do you know from your indices laws that this is? What's 2 to the -1? That's the same as a half. Okay, so the final answer is this. Gee, I hope I'm not going too fast. You can always slow this down. Just go to the preferences and just slow the video down. If you don't know how to slow a video down on YouTube, you'll see this sort of little symbol at the bottom, and you just press on that and go to Geschwindigkeit, and you can make it slower or faster. Remember, think of this as multiplied by -1. So now we're going to go, this is going to be the same as this. Now that's the inverse. Remember, this is the inverse. So now we're going to go the other way. This is just going to be 2. Final one in this series. Remember, this is just, think of this as multiplied by -1. So we have 1/4 to the power of -1, and that's just simply an inverse again. So that's just natural log of 4, and that's the end of that question. I just realized I wrote that down incorrectly because there's actually a 2 here. So if there's a 2 here, this is going to be -2. Let me just do that in red. I didn't see the 2 here, so now it's going to be to the power of -2. So that would actually be the inverse but squared now. So that's the actual answer is this. I didn't see that 2 there. So -2, so it's the inverse of that. So it's log of 1 over 4 to the -2. Just invert that and you get natural log of 16. So that's what we're using here is the exponent laws together with the log laws, and they're very, very tied together. This question is asking you to explain that the natural log of 27 is the same as 3 times the natural log of 3. Well, that's not so difficult because we know that this is the same as that. And 3 cubed is 3 times 3 times 3, which is equal to 3 times 9, which is equal to 27. So you've just shown that, and that's how you would show that. Now, similarly with all the rest of this section. So show that the natural log of the square of 3 is equal to half natural log of 3. Well, that's because this is the same as 3 to the half. And using your log laws, that's where you would put that. So all these are doing is asking you to use the log laws to show these two different ways of expressing the same thing. So now we obviously have to have a minus there because it's the inverse. So this is 2 to the minus 4, which is equal to, remember it's inverse, and we know that 2 to the power of 4 is 16. So that's how we've proved that. It's not really a proof, but we're just demonstrating using the log laws. So we know that this is going to be that because we've seen this as -1. Okay, so 6 to the power of -1 is the same as 1 over 6. So that's how we get that -1 there. And you should be able to see the similar thing here. Square root of 2. Well, this is obviously an inverse of square root of 2. So that's going to be -1. Sorry, -1/2, because this is a square root, remember? So that's 1 over 2 to the half. That's how we would express a square root. And then I just take that outside of the log of 2. So that's giving us the square root, but also the negative here is going to inverse it. So that's how we get that. F is an interesting one because we're using the natural log, which we know is base e, of e over 5. And why is it 1 minus natural log of 5? Well, we know that the minus comes from the fact that it's an inverse, but where does the 1 come from? That's because we've ended up, if we use the log laws here, with the natural log of e minus log of 5, and this is 1, because what is this telling us? This is telling us what power gives us e again. So it's got to be 1. E to the power of 1 is e. So that's where our 1 comes from. Question 4 is the same. It's just testing your log laws, and you should be able to see that these are not very difficult. This -5 comes from the fact that 32 is just 2 to the power of 5, and of course it's the inverse, so we need the negative. This is the 5th power, so that's why we've got that. Again, it's an inverse, so we need the negative. This one's a little more difficult. This is saying what log of e gives us 2? Well, it's got to be e squared. So we can just change that to this minus, and let's immediately move this to 2 cubed. So we know from the minus log laws that that's going to look like that, which I may as well just immediately write as 8. Does that make sense? I hope so. Question 5 is a bit trickier, but again, it's just identifying your log laws. So this log of d is equal to, well, let's change this 1 straight away to the natural log. How are we going to get the 1? Well, we're just going to say natural log of e, remember? So e to the 1 is equal to e. So that's how we get that 1. So if this is plus, then we can just use the log law of x times e. Therefore, d must be equal to x times e. And that's how we express that equation. That's exactly the same as that. Does that make sense? So I'm just using different log laws here, but I needed to recognize that I could express that as that. The next question, remember this is just multiplying by -1, so using our exponent laws, that goes here. And 2, well, that's got to be e squared. Okay? Because remember this is all e. So now let's move this, let's put these together, multiply these together. So e squared, and I may as well put that as e squared over p. That means that f must be e squared over this is the same as x to the half, which of course is the same as that, square root of x, it's ln p. So simply p is equal to the square root of x, and that's the solution. D, natural log of m, is equal to 2 times the natural log of y plus 3. So we need to see, how do we get that 3? Well, we just call that the log of e cubed, right? Because this is base e, so the log of e cubed is going to equal 3, because it's saying what power of e gives you e cubed. Well, it's 3. So moving that into the equation, we'll move this to y squared, so that's another log law that you should know, plus, so let's now multiply these, y squared times e cubed is equal to natural log of m. Therefore, m must be equal to y squared e cubed. Again, in question E, let's recognize that that is just the same as negative minus ln of e, so that's 3 ln t. So we can put this immediately as t cubed over e. Therefore, b must be equal to t cubed over e, if I want to express that this way. Continuing with looking at our log laws here, what does this mean? Well, that is going to be ln of g to the minus cubed here, which is the same as 1 over cube root of g. You can write it either way, doesn't really matter. Therefore, n is equal to 1 over the cube root of g, or 1 over g to the third, or g to the minus a third. Any of those is the same thing, really. Be careful in this question that this sign means approximately equal to, so your answer is also going to be approximately equal to. So how are we going to change this around? So we can immediately say this because you know that law, but what is this going to be? Well, in order to find out how we can express that as a natural logarithm, we need to find what is e to the 2159, so we can express that as a natural log. So if you enter this into your calculator, you'll come up with 8.66. So basically what we're saying is that e is to the 2.159 is the natural log of 8.66, okay? Because remember, this is saying this is asking what power of e gives you that. So that's what we've done. We've just changed it into that. So now I can multiply that around a bit. So ln x cubed times 8.66 is equal to q. So final answer is q is equal to 8.66. Oops, I nearly made the same mistake. Approximately x cubed. Okay, so approximately, that's one thing to remember. Okay, and also I only did this to 3 significant figures, and that's not accurate, so hence this as well. Final question. So we can automatically say that this is n to the 0.4 using our log laws. Now, what is this going to be as a natural logarithm? So what is e to that power? We need to use our calculator for that. So in the calculator, I just entered e to the 0.6582 to come up with the answer for the log. So this is going to be approximately a natural log of n 0.4 minus the natural log of, looking at my calculator, 1.9 3 using 3 significant figures. So D is approximately equal to, and now we're going to use the log laws here, natural log of n to the power of 0.4 over 1.93. Sorry, that's the natural log there. So final answer, D is approximately equal to this. Now that looks a little bit complicated, but it's not really. If I want to express this as a number, I can just say 1 on 1.93 times n to the 0.4, and I can find this out in my calculator. That's the same as 0.518 n to 0.4. Either is acceptable. You can have said this or this. Except, what does the question say? Write the following without logarithms. Yeah, so either is okay. It's the same thing. I just, on my calculator, I just said what is 1 divided 1.93, and that's the answer here. And remember, use it to 3 significant figures unless otherwise stated. So that's the end of that worksheet.